We'll go ahead and get started. So thank you for joining. This is the 2026 Web Science and Digital Libraries Research Group Research Expo. And this is where we get a chance to get together virtually and have some of our students give presentations about what they're working on, as well as hear from faculty, alumni, guests, friends, potential members of potential future members of WSDL, etc. We'll start with a faculty introduction. I'm Michael Nelson. I've been at ODU since 2002, and I'm one of the co-founders of the Web Science and Digital Library Research Group. And my research areas are web archiving, digital libraries, the intersection between web security and web archiving. Let me see, one of my students will be presenting, actually the first one up. So I've been around for a while, full professor, and I'm glad to be here and happy to hear from you. Let me see. Dr. Weigel, would you like to go next?
Sure. Michelle Weigel, professor of computer science, but now my main job is associate dean of the graduate school. And so I'm still involved in research, at least in terms of getting my students graduated and co-authoring on work. But a lot of my focus now is on helping all graduate students make it to their degrees. Himarsha is going to be presenting. I think she's the cleanup hitter on our list today.
That's a baseball reference for those who are born outside the U.S. I'm not sure I'm sure there's a cricket analog for it, but I'm not sure. All right, thank you. Let me see. Since we're on a dean run, Dr. Jayaratna, would you like to go next?
Sure. Sampath Jayaratna, I'm an associate professor of computer science. I'm at the honors college right now, so it's part of the undergraduate honors program here at Old Dominion University. I'm the assistant dean of the student affairs at the Perry Honors College. So if you don't know what is an honors college, basically we recruit top students who are coming to ODU. For example, in the freshman cohort this year, we have about 750 honors students who are the top performing scholarship recipients. So this is a big deal because I think this is one of the biggest honors college cohort that we recruited this year. So we are pretty excited about that. You know, we are doing a lot of programs for them, events, orientation, various other activities and academic professional related activities with them. So these are, I mean, this year we were looking at their GPA. Our average GPA is very close to 3.95. Oh, you know, I would say majority of them are 4 or more, 4.00 or greater. So we are very excited about that. My area of research is in eye tracking, human-computer interaction, lately focusing on a little bit on drones, as well as some of the startup work that I'm doing with my students and Dr. Banuka, who's recently graduated, who's going to be here. That we got some funding from CCI program to focus on some of the startup work that we are doing. Very excited to see everyone and excited to hear some research. Thank you.
Thank you. That's excellent. So let me see. How about Dr. Wu? Would you like to go next?
Sure. Hi, everyone. My name is Jian Wu. I'm an associate professor in computer science. I joined ODU in 2018, the same year as Sampath. I'm also serving as the graduate program director of School of Data Science. So my research interests are natural language processing, scholarly big data, information retrieval, the digital libraries, and the science of science. And today, my student Rochana will present his WSDL long paper, CC30K, a citation context dataset for reproducibility-oriented sentiment analysis. Rochana has been working a lot on the sense of science domains, working on reproducibility and replicability work. Recently, he got a co-authored paper accepted by KDD, which is a top-tier computer science conference on data mining and knowledge discovery. My work has been supported by NSF, MLS, DARPA, and Open Philanthropy. Very excited to join this Web Science and Digital Library research group and then hear the research from other faculties and students.
All right, excellent. Thank you. I think Dr. Vikas Shak said he had a user study at this time, if I recall, but I believe I saw Faryana on there. Are you
Yes,
there?
yeah.
Oh,
Yeah.
excellent.
Hi, everyone. I'm Faryana Porsardar. I'm research assistant professor at the OERI, Office of Enterprise Research and Innovation. And I have joint appointment with Interdisciplinary Schools, School of Data Science. I've been at ODU since 2020, and my research interests are in human-centered AI, kind of real-time decision-making support for intelligent systems. And I also have previous works on digital libraries, web archive, and so this kind of thing. I'm excited to hear about all of the research that you are doing at WSDL. Thank you.
All right. Thank you, Dr. Porstar. Let's see. I'm going through, I know a lot of the alumni, like Justin Matsud, said they couldn't be here right at 2 o'clock and will join later. I'm not sure I'm seeing. If I'm missing someone, please let me know. Scrolling through, I don't think I see. So we'll fit them in when they actually get here. So I'm going to stop sharing. Brian, I think you're going to be up first.
Yes. Can you hear me well?
Yes.
Okay, perfect. Let me share my screen. Okay, it's popping up.
All right, got it.
Okay, perfect. Okay, hello everyone. Welcome to the Research Expo of this year. So today I'm going to present my work in progress, RAG-TEC, extracting and classifying topics in digital news collection using large language models. My advisor is Dr. Michael Nelson. So one of the main objectives with this work in progress is how can we analyze digital collection in this particular context, focusing on digital news related to any particular event. So one of the goals that we want to aim here is how fast and how much we can learn about a collection without relying on manual inspection of the materials. So let's see, in this context, I want to learn about 180 countries around the world. So let's pick one random country in the Africa. So as a Colombian, my knowledge is very zero related to African countries, but let's see, I want to learn about Mozambique. So if I want to learn about Mozambique, okay, I can take a look on Wikipedia. And what I found about Mozambique is a country located in the southwest of Africa. The country was colonized by Portugal in 15th century and remained under Portuguese rule until 1975, where after a long and bloody civil war, Mozambique gained independence. But that is about historical information. But what if I want to learn about what's going on today? So something that I could do is rely on news articles, and then I could read the news to check what is happening. So there are tons of news outlets that I could check, but let's pick three news outlets that may find more relevant information about what's going on. It could be Reuters, it could be of Africa or African news. So let's see, I pick African news and I found a news article about what happened in Mozambique last year. So at that point in October, it was an election, but they killed two prominent opposition figures. But something happened, right? So something that I could do is, okay, let me take a look on the article. If I want to have a aim understanding, I could read the title, or even though I could write a summary of the entire news articles, and then I can have an understanding on that. Or even though after reading the news articles, I could identify the topic of the news articles, and in overall, I could say, okay, this news article is about the Mozambique opposition assassinations. If I want to do more sophisticated stuff, something that I could rely is on identify the events that are mentioned in the article, or even though I could do a mind map to get a contextualization. So in that sense, I was able to read one article at a time, right? I could do a second one, I could do a three. But what about if I have n number of articles? So in overall reading many news articles and understanding a collection, it could be time consuming. So the challenge here is that, okay, understanding a news collection is time consuming, and then we need a rapid and reliable contextualization through thematic understanding. We could understand a collection from many facets or perspectives, but let's see, I want to understand through a thematic component. So rely on methods or algorithms if we want to get a contextualization by identify topics. There are two well-known methods. One of them is latent direct allocation, LDA, and the other one is word topic. Both of them have advantage and limitations, but the reason that word topic was built is first relying on the transformer architecture, but also address the limitations that LDA has. One of the many limitations that LDA has is relies on back of words, and then you will need to specify the number of clusters in this context topics. And also, it fails to capture contextual nuances and relies on predefined rules. So, bare topic, since it's a semantic contextual representation of the text, so we could leverage depth neural networks to learn rich contextual representations. But as a method, it has as well some limitations. So one of them is that assumes that each document contains only a single topic, which may not align with real world cases. And still, topic representation is still based on back of words, leading to redundancy and less informative topics. So in those days, we could rely on LLMs. So the question here is, how can we use LLMs to extract and classify topics from news collections for rapid contextualization? So large language models has been known to perform different tasks. It could be performed for summarization and interpretation. It could be as well to perform for entity and even extraction. And then also it could be performed for domain-specific insights. So in this context, for understanding news digital collections and rely on the use of large language models, so we propose a framework, RAG-TEC, Retrieval Augmented Generation for Topic Extraction and Classification, which is a 5-stage framework divided in first, collection generation, second, topic extraction, third, topic classification, fourth, topic quality, and lastly, topic storytelling. So first, we manually curate for collections. So the step was to rely on the live web. Then we manually collect URLs from news outlets. Then we use the web archive version, and if doesn't exist, we archive them. And then for each individual website, we extract some metadata using the schema ORG protocol, and then using an scraper to get the content of the news articles. Once we have those information for each one, we create a structure or template that LLMs could use, where the header of the template, it has all of the article metadata information, and the other part of the template, it has the article body. So once we have those templates for each URLs, we store them in a database. So for that, we use 4 collections for different 4 countries in Africa: Burundi, Democratic Republic of Congo, Mozambique, and Sudan. So here you can see that initially we collect some seed URLs, and then after validation, we have less URLs to analyze. So then we, instead of relying on the entire collection, we summarize that collection to selecting optimal K values. And as you can see here, it may depend of the size of the collection. And then also here we use a percentage of URLs for the next stage. So once from top K relevant documents with the collection, so we use GPT-4o Mini to extract the topics. So the overall framework or process, first we generate a query that allows us to retrieve relevant documents, and then for the database that we generate in previous stage, we generate some embeddings, and then we store them in a vector database. So that vector database allows us to match the query with the relevant documents by using cosine similarity. And once we have those K relevant news articles from the collection, we use GPT and we use zero-shot prompting for extract topics on that collection. And after that, we can have a collection context based on the list of the topics, the explanation on why those number of topics, what is the collection about, and for each topic, we have a topic name, a description, and a set of keywords. So here, the LLM serves as an information extraction model. So as you can see here, this is 6 resulting topics from the Mozambique collection compared with the LDA and BER topic. And then, as you can see here, we can notice that our framework provides more human interpretation of the topics compared with LDA and BER topic, which, for instance, for LDA, we have a set of keywords, while BER topic provides kind of like a name based on most relevant keywords. On that sense, we can have a glance of what are the topics within the collection based on relevant documents. But then, since the topics were extracted based on relevant information, we need if that process was good or not. So to assess that, we use GPT-4o Mini to classify one document into one main topic and many subtopics. So here we don't need first to train a machine learning model, and then also the LLM serves as a classification model. So as well, we use a zero-shot prompting, and to assess whether the topics were enough or not, we ask to the LLMs, like based on the set of list, if there is no any topic related to the documents, generate one extra topic. On that sense, if the LLMs generate more topics, that means that the process of using relevance documents was not enough. So as an output, then we have the list of topics, and as well we have for each document, we have the primary topic and the subtopics, and then we have as well the reasoning of why that topic is relevant for the document. So as you can see here, compared with BER topic and LDA, where they rely on one document and one topic assumption. As you can see here, of course, most of the documents within the collections, they could have one topic per document, but we can see that most of the documents can have between 2 and 4 topics. So now that we have the classification of the topics and the topics extraction, we need to assess the topic quality for the collection. So for that, we use topic diversity and coherence metric that are well-to-known metrics when it comes to topic modeling. So, and then our framework, since we use LLMs for extract the keywords, which the keywords are going to be very helpful to assess that. We also propose to combine the use of KeyBird, which is a transformer architecture model that, based on a corpora, is extract relevant keywords. So once we have those keywords and then we assess the topic quality, we can see here that in overall, our framework performs in diversity, while LDA performs of better in coherence. Coherence here is more about if the topics that are generated by the model are enough for the collection, while diversity measure how separate are the topics regarding the documents. In that sense, since we want to maximize understanding, what we care is more about having as much as a topics we can, but without reducing the performance of our framework. So additionally, for instance, here we can have the topic description. For instance, we have election violence and a description about what is the topic about. And then here we can see the difference between the keywords generated from our framework and also the keywords generated by KeyBird enhancing our framework. So actually, as you can see here, those of them provide a different understanding of the collection. But in overall, we can say that this topic is more about election, opposition, and violence. So these keywords, they could be used to use in search engines to search more news articles or more relevant information about any particular topic, about this particular topic. So finally, now we can understand the collection from a topic perspective. We don't rely on manual inspection. So we propose 3 visualizations based on those topics. So once is just the collection context, which is I showed previously, which is the topic description, the list of topics, what is the collection about. Then we have a topic concurrence network to see how is the correlation between topics and how they close they are within a document, and then the topic distribution. So as you can see here, we can first have a overall understanding to see what is the most topic mentioned in the collection. So in overall, most of the news articles for the Mozambique collection, they are about election violence, but also they talk about climate challenge. So, but now I want to understand when a topic is mentioned in the collection, what other topics are mentioned about as well. So for instance, in this collection, I can see that when the documents mention about election violence, somehow also there is a relation about social media restrictions. So that means that those topics are mentioned at the same time in the collection, but the difference is the preeminence. So in overall, election violence is like the main topic of the collection, but also there are other relevant topics. So limitation of this work is first, it's a small and manually curated collection which introduce selection bias and limit scalability. Also, topic output is sensitive to prompt design and model behavior. Also, evaluation was done without a goal and startup label. And then current approach use only GPT-4o Mini, so prompting strategies and open source LLMs remain unexplored. So saying that future work, it should focus on experiment with diverse prompt styles and open source models. Also automate the collection building to reduce manual selection bias, and then expand method to multilingual and cross-national compora for comparative analysis. As a conclusion, RAG-TEC bridge interpretability and automation for topic modeling, emphasize actors, agency, and mechanisms vital for qualitative and mixed method research, produce topics usable as initial codebooks from framing analysis, complement existing models by adding narrative richness and contextual sensitivity, demonstrate utility through 4 collections extensible to other manually curated collections, and finally, RAG-TEC empowers researchers to move beyond shallow topic labels and uncover the narrative mechanisms embedded in news discourse. Thank you so much. I'm open to any questions, comments, or suggestions.
Thank you, Brian. Excellent. Questions for Brian? Nobody wants to go first, right?
I have one.
Okay, excellent. Thank you.
Jim has. Sorry, I can't remember how to raise my hand in this. So, yeah. So my question immediately goes to the topic extraction that you're doing with the zero shot prompting. Are you doing anything to evaluate how much you can trust whether or not the topic that gets extracted is actually like within context, within correct context of the article itself?
So that is a good question. So basically what we did here, it was to rely in subject matter expert. With the previous advisor I was working on this work, he's an expert on assessing complex societal systems. So basically, we discussed, we did a qualitative discussion and assessment on where the topics were enough or not, since he was one of the experts that create the collection. But to measure how good was just that first stage of topic extraction, we didn't do a manual inspection. So of course we need to assess whether that extraction was good enough or not. However, I will say that the way to assess quantitative was through topic quality and topic coherence, where are the two main metrics that, when it comes to topic modeling, researchers use to assess whether the topics are good or not, since this is an unsupervised task. So, for instance, if you use LDA Amber topic, you don't have a golden standard label dataset. So, on that sense, the only two metrics that you could rely at this point is using topic quality and coherence, and of course, qualitative evaluation. But thank you so much for your question. It makes sense, but no, the question is just we didn't do that manual inspection first.
So, John, you have your hand up.
Yes, Brian, thank you for your presentation. It was a great presentation. When you were presenting, you mentioned that this is for rapid understanding of, let's say, a collection of news, for instance, to know like what's happening in a country. So I wonder, or I'm thinking about trying to understand the value of the topic as a final output, because thinking about how people consume information, like for instance, since your method is a RAG-based approach, why do you think we should focus on extracting topics instead of, let's say, generating a narrative from the news collection you have there? For instance, because if I ask like what's happening in Mozambique and I get a narrative from what is happening, probably that would be more, I don't know, like meaningful or like easier to understand, because I'm gonna have a narrative of what is happening. Why would I need to rely on topics rather than a narrative and then evaluating the factual accuracy of the narrative based on the documents, for instance?
That is a good question, John. Thanks for asking. As I mentioned at the beginning of the presentation, actually, there is not a only way to understand a collection, or even though there is not a only or unique way to understand a news article itself. So, for instance, here, I have three different ways to just only understand a news article itself. A person could just understand the article based on the title, or there are more people that they will need to read and then summarize the article, or you could, for instance, identify what is the topic about the news articles, and then you can have an understanding of that, right? Or even though you could identify the events of that news articles, generate a timeline, or you could do like a mind map to have an understanding of the entire news articles. So this is just like a first glance of assessing one of the many perspectives that we could do. For instance, also reading about previous work, Dr. Jones, Sean Jones, he was focusing on summarizing collections using story cards, for instance, giving a large collection, how we can use visual tools to understand a collection. So there are many ways to understand a collection, and then one of the, for instance, the first stage, which is about topic extraction, as you mentioned, since I'm relying on retrieval augmented generation. In that part, I'm not only asked about what are the topics about, but also, as you can see, I'm not sure if you see my cursor, but as you can see here, I generate, the tool generate a summary of the collection. So we can have as well understanding of the entire collection based on relevant information. I'm not sure if that answered your question,
Yeah,
but
yeah, makes
again,
sense.
yeah, sure.
Thank you.
Thank
Yeah.
you for your question.
So, Brian, I have a question. So this technique in general, what is specific to news, right? Could this be scholarly articles about the topic, in this case, Mozambique? Like, could we go to the Wikipedia page about Mozambique and essentially grab all the references, which would surely include news, right? But presumably include other things, right? And even for such a broad topic as Mozambique, there are surely sub-articles, and you could sort of do a recursive grab and build your collection from that. And I think this gets a little bit to Jim's point, perhaps, how do you evaluate this? How do you know if you've done a good job? And if if the if the task has a built-in assumption about news, then it is what it is, right? But if your goal is to learn about Mozambique in this case, why limit yourself to news?
Right. So that is a good question, Dr. Nelson. I really appreciate it. So first of all, in overall, this tool is not just on. It doesn't work only for news articles. Even though the collection itself or the database itself was built based on news articles, just in this particular, in the database, it could be many different type of documents. It could be Wikipedia. It could be different sources, right? So that is, it could be used our scholarly documents as well. But in that sense, the assumption here is like news articles, in overall, it could serve as a starting point on understanding what is happening, for instance, in this context about any particular country, right? If we want to understand what is happening in a time window or what is happening in a certain point of time, I think that news articles is like the first starting point that we could use in terms of digital sources. I will say that Wikipedia sources, for instance, they will help us to understand like historical uh, information or historical components of that particular event or country. I know that some of the wiki information was built using news articles, for instance. But in that sense, our assumption here that is that news articles uh, are a good starting point for understanding about what's going on.
Okay, and it occurs to me, it might even be possible to use Wikipedia as a ground truth, right? So
Yes.
for very big topics like Mozambique, there are the section headings within the article. Again, any sub-articles, geography of Mozambique, economy of Mozambique, that surely just, branch out into whole separate pages. I wonder if you could mine that as a structure and then see how well perhaps the news or collection populates this structure, right? If you view it as like decorating a tree, whether or not you get even-ish distribution of ornaments on your tree.
Yeah, actually, yeah, that is a good, actually related work in terms of collection generation. It focused on use Wikipedia as a ground truth, as you mentioned before, and then compare each individual, for instance, news information against the Wikipedia source to see how similar they are. And based on a threshold, is where you select if that article is good if enough to explain about where you are interested to look for. But again, I'm still exploring how to assess that topic extraction at the beginning. But in that sense, we rely on subject matter expert to see if the topics were good enough or not on that first stage. But actually, that is a good comment that I will consider for my dissertation.
All right, excellent. So I thought Lawrence briefly had his hand up. Lawrence, you there?
So I had a presentation. I since ChatGPT for I just wanted to I know this model has been retired. You said it's like a work in progress. Have you tried to update it to the more recent models? And if you have, are there changes? Does the system get better, or it's still just the same as it were before? If you noticed any change in that regard.
That is actually a good question, Lawrence. Thanks. No, so far I haven't tested any other update models. But as so far as I know, and the models that we have been testing, GPT-4o Mini is sort of like the best in terms of price and quality. But no, I haven't explored other commercial or either open source models.
All right, thank you. Jim, you had your hand up.
Yeah, it was just a quick thing. When you're talking about Wikipedia, I put in the chat Wikidata. It's a data source or a data set created for Wikipedia, and I use it in a side thing for building knowledge graphs. So it sounded exactly like what you were talking about, trying to construct a kind of mind map of some topic off of Wikipedia and all of its subtopics and everything. So you could grab kind of like a graph or network graph, knowledge graph of the wiki data, and then follow it, a couple hops and create like a local kind of thing.
Okay, thank you, James. I really appreciate it. I will take a look. Thanks for the advice.
Yeah, real good point. All right. With that, I think we'll wrap up Brian's presentation. Thank you so much. Lawrence, you're up next on the agenda.
Okay, let me share my screen. Can everyone see my screen?
Got it? Yep.
Hello. Can you hear me?
Yes. Thank you.
All right. Good afternoon, everyone. My name is Lawrence. I'm a PhD student, computer science, working with Dr. Sampath at the department, and then I also work in VMAS with the OIR people. Dr. Jessica is currently my supervisor at VMAS. So I want to more or less present my paper, an extended abstract called the Cognitive Prosthetics and AI-enabled multimodal system for episodic recall in knowledge work. Cognitive prosthetics means any external tools or devices or software that you can use to augment or support human memories, just to take the load off a human being a little bit so that they can more or less focus on things that are important. So we had it published as on this year CHI as an extended abstract. So the problem we're trying to more or less solve, so in knowledge work, I think most of us are in knowledge work. We work at the offices, we have our offices, and we do different works most of the time. But then when we're working, there is always we notice that there is always like fragmented attention. So because you focus on different things at more or less at a time, there is always like frequent interruptions, and there's always like rapid context in terms of switching between what you're doing. You can be looking at the screen, you can look at your colleague, you can look at, so there's always like a different switching of contexts happening in whatever we're doing. So the work, it's more like important in information, like in exchange. So everything we do happen in terms of like we're spoken dialogues, wherever we're looking at, and then what is happening in our brain at that instant, and also like how our body responding to the state we are in, more like how our heart is beating, how our skin is responding at that point. So there are like tools already there where people can, the note-taking tools, there are video recording tools, there are like transcription tools like Zooms and all of that. But then these tools don't take the context, the environment where the person is into consideration at that time. So that is why we proposed a system called like cognitive prosthetic, like multimodal system. They more or less bring all of this context together, like speech transcription. So when you're in your office, you're talking. When you're in your office, your skin is responding. When you're in your office, you're like your eyes are looking at everything. So using things that we do more like just looking at this image, you could see like somebody in his
Lawrence, I'm going
office.
to interrupt for a second. The window of me is showing up on the screen and covering up a good chunk. If you could dismiss that. I think that's going. Okay, excellent. It's gone. Thank you. Sorry to interrupt.
Okay, it's fine. So so if you look at the image, you could see someone in an office. So we're having the person wearing an eye tracker. Eye tracker just to more like gauge, capture what the person is looking at, and then we have like an emoji bit, just like your Apple Watch, your Samsung Watch, that is able to capture your skin responses, your heartbeat, your blood pressure, and your respiration and all of that. And we also have like a device we called Resetter we build in the lab, more like something you can put on your table that can record your speech at that point. And then we build also like a retrieval system. After getting the eye tracking data, after getting the emoji bit and the speech data, we're able to more or less process all of that and put into in a retrieval system where the user or you as a person, you can go back later to go and more or less retrieve what was discussed and how more or less you responded at that time, what you were focused on or what you were looking at. So that is the context and the system we're trying to build to solve the problem of the problem we look at. So the system architecture is more like, again, looking at somebody in a workplace or in his office. We have the Rosetta, which is like capturing speech. We have the eye tracker, which is more like capturing where the person is looking at, whether you're looking at your computer or you're looking at us. We're just more like having that world view where the person is looking at. And then the person wearing an emoji bead, just to capture how your skin is responding, how your heart is beating at that instant, and maybe your body temperature and on all of that. And then we extract those data from those devices and more or less process them in a JSON nano, more like edge computing, something to process the data. And from that JSON nano, we are able to more or less call the data into like your computer or a system where you can go later to more or less query what you have, what this data is saying. Yeah, from that. Yeah, so we build like a more like a dashboard. After having getting those data processed, we're able to import them into the retrieval system. And a user can more or less go back to this system. The goal is to more or less, when you are in your office, rather than if you know that you have a system that you can go back to later to be able to ask questions and all of that, you are able to be more present in the meeting. Maybe you take less note and just more or less focus and on things that are important in that situation we are trying to capture the data from. So after getting the data, you're able to come back to the retrieval system to be like, oh, query the system in a way that in a way that, or like what was discussed at the time. So everything here is like time synced. So you're able to like come back and ask, or what was discussed during a particular time or high stress time? When did we talk about database migration? What decision were made during that meeting, yesterday meeting? So you're able to more or less come back to query the system. We believe that this more or less take a lot of cognitive load from the person during that meeting time. And then also in the system, because we have the hard data and every into the retrieval system, we're able to visualize like what was your heart rate when certain decisions were being made? Where were you like more or less stressed at that time? What was your skin saying? What was the high load moment at that particular time? So more or less, the retrieval system is time-based and it more or less aggregates physiological statistic from the person, and then it's more or less also give you a context aware because it's time. If you initially had a meeting of like 30 minutes, you are able to go back to that meeting each of those minutes, more or less try to see what happened at that point. And so again, our key contribution into this into our work was more like being able to have an AI-enabled multimodal system that capture all of those human data and environment data and context data and be able to bring them for the person to use again. More like again, multimodal integration. Most of the research already like have speech separate, gaze behavior separate, physiological data separate, but our system is able to bring all of them into more like a structure representation where somebody is able to make sense, not just from the eye tracking, not just from the physiological data, not just from the speech, but from everything. So you're more or less looking at everything. And why designing the system also, one of the major problem major concern that we have is more like privacy. Because we are dealing with human data, people are always very cautious of like, oh, where are you keeping my data? Where are you storing my data? Where are you, even when we're applying for IRB for this project, it's, that is one of the concern as well. People are super protective of their data, even though I believe all our data are online already, but most of them, but people still want to know where their data be kept. So we had the Jetson Nano, just so that we are able to bring the system to a local, more like have the system with the person if possible, just something to put on your table there so that all your data are more like processed locally and not like moved to a third party. That is one of the goals, which I think is one of our contribution as well. And then integrating AI into the system to be able to help with the retrieval. We also had like a lot of privacy concern with the model because most of the models are like third party Someone is always like, if you put my data in, even after the processing, and the AI have access to the data because you're querying it, and we put in the AI to be able to give you a lot of context. People will see more like, oh, maybe I have access to my data, but one of the how we're mitigating that is just letting people know in time. In the user study that we're going to conduct, that yeah, your data is going to be accessed by a third party AI model, so that we're able to like overcome that. So our future work, we currently have an IRB submitted for this work, which is to allow us to do a user study where we have participants in their office setting, more like wearing these sensors and collecting data, having different kind of meetings so that we can more or less test the ruggedity of the system and how it's able to more or less help people, even though we more or less know that it will help people already. So another thing is having it deploy in a real work environment. So more or less, what kind of environment we want to deploy this? Is it like maybe an individual office, or is it like an office setting where the device is more or less belong to the company kind of thing? And another thing we're also looking at is whether if multiple people are having a meeting, should that data be more or less seen as an individual data or like a group data? So we also build the dashboard in a way that we are able to separate those data to be like personal or like a group data, and be able to prompt in that regard for like the retriever as well. And accessibility, we're looking right now. Our design is more like an able-bodied person in the workplace, but we're also looking at different user population like ADHD people, and visually impaired people, and then autistic people, depending on which users we are able to find during our user studies. We go ahead and then we're also looking at sensor expansion. We have emotive, we have eye tracking, we have speech. We want to also add like environment sensor, where you can be like, okay, we want to know if the environment also have effects on the person having the meeting. Maybe if you're having a meeting in a hot place or in a cold place, if there will be like differences in the output from the data that the person have. Yeah, so thank you very much for the opportunity to present my work to you guys. Any questions you have, and any suggestions, I would very much appreciate. Thank you.
All right, thank you. Thank you, Lawrence. Questions for Lawrence? Who wants to go first? All right, so John, you had a question.
Yes, thank you, Lawrence, for your presentation. It was not clear for me the importance of the study. Like, why do I need to have my heart rate, and like why do I need to go back and like do a query about my heart rate and all the gates, and yeah, like heart rate, GSR, and everything like that? Why do I care about that? Because I'm busy, I'm trying to work, right, and going back to my notes. So why do I need knowing my heart rate, like the importance of this?
Yeah, thank you for the question. It's very important. Why this study is important? Again, it's like you said, you're a very busy person, and if you're having a meeting, if you're busy, let's say, rather than take notes, you have something that takes note for you because it's recording your speech. Rather than again, when you go back, we want to see what, for the eye tracking, we want to see what your attentions were focused on in the meeting.
Yeah,
What you
but why?
were, okay. The reason being that if attention is more or less very important, if the reason, like, attention is very important in the sense that if you're switching contexts in everything you're looking at, it's important that if you go back to check this data, more like you're trying to recall whatever happened in that meeting. We also want to know what you were looking at that point when when maybe a decision was being made in the meeting, where somebody is maybe a deadline was being set, where what you were looking at. And then for the heartbeat, we wanted to know how your internal body is responding. Were you relaxed? Or if you hear that, oh, there was a deadline, were you tensed? Were you stressed? Those are the kind of data result we're interested in from the heart rate. What we were looking at was its importance in a way that it helped us to more or less understand your attention level at that point, maybe when the meeting was going on. Were you looking distracted? Were you just looking everywhere? Your gaze was just moving everywhere. Maybe not like just a meeting. Maybe you were doing a presentation, or maybe you were in a training. We want to more or less look at what were you looking at. More like where your attention was. I think that is the importance of the eye tracking. I don't know if I was able to answer your question.
I mean, yeah, I understand like that you are tracking that, but I still don't get the why I do
Well,
have to know.
let me jump in. This relates to the question I have written down. So this really strikes me as essentially being very similar to monitoring a pilot, right? Or some kind of equipment operator. You're in a cockpit,
Yeah.
and you're part of the machine, right? Now, we typically don't think getting online, getting on our laptop, browsing the web as being the same thing. But this sort of monitoring the human in the loop strikes me as treating the operator as a pilot. And that might not be so far-fetched, right? And to the extent of, yes, I'm at a desk, I'm looking at a screen, but maybe I'm a drone pilot. Maybe I'm doing some kind of uh, um, application, real time, real world, connected to the real world activity where it is important for me to be monitored for, heart rate, stress level, basically human reaction, human performance. Am I on the right track, Lawrence?
Yes, you more like different application, maybe like a driver,
Mhm.
you were driving, like what were you looking at just in case like an accident happened and somebody needed to like review the situation. More like what were you looking at, what your attention was, what were your heartbeats and stuff. So the application is more like wide but for this study we just more like I mean for this presentation more or less just focus on like somebody in an office setting, but it can be applied to
Right.
different situations. Yes.
Yeah,
And
yeah, thank you.
And also, just to add what Lawrence was saying, this is probably going to be more important for us to understand from people who are on the autism spectrum, people with ADHD, because that's where these physiological measures going to be very, very helpful. Because when understanding their status. For example, early warning when they are overwhelmed with something, and that gonna help us pinpointing, all these information that we can collect together at the same time. So we start with this building the system because it help kind of a little bit differentiate from this particular domain because it's harder to collect data from these people. So we want to build the system, collect data from subject in a particular domain, but our plan is to kind of focus on this particular demographics. Hope that answered the question.
Yes, it makes sense, especially because my question was because I was thinking one of the things I read in Future World was the evaluation of the system. So I was wondering like how that was gonna be evaluated and whether there was any baseline to evaluate these against to anything. So yeah, it answered my question. Thank you.
Could this be used in a commercial setting where maybe someone wants to know people's reaction to their products that they're saying, to see what products or what design have some kind of emotional response? Maybe you're doing game development. You want to find out what parts of the game are drawing. Maybe if it's a horror versus another genre, you want to see how people respond to it, and you're able to use all the eye tracking information, the skin sensors, just to see how people's physiological responses to what they're seeing, or even movies, or even products. Because what people say versus what they feel and how they react might not always correlate. So if you're reading exactly how they're feeling, that could help you tell whether your product is garnering some kind of emotional response.
Yeah, thank you very much, Dr. Wala. Yeah, I think again, emotional, one of the reasons why we measure like physiology and eye tracking and all of these data is that in terms of emotion, it's always like if people are smiling, people are smiling or saying something, they can always fake those things. But like heart rate, skin response, those internal measurements, we're able to be like, oh, the person doesn't really have too much control over them. So whatever data is coming from them can be seen as like more authentic than just facial recognitions and all of that. Thank you.
Thank you, Dara. Makes sense. Yeah.
So you could definitely apply this to sports as well, right? Monitor the interaction with the fans that are watching. And for all the people, in the room hooked up, you could figure out who's really paying attention versus just there for the food or something. And then you could also apply this on a global scale, right? Where if the fan base for one team is more engaged, right, they get some kind of real world benefit or something.
That reminds me. Sorry, that reminds me, what you just said, Michael, just reminds me of, I don't know if you've heard those political debates where people have where they have like focus groups and they have dials that they turn, whether they are favoring one candidate or another.
Right.
And that's a very mechanical way of dialing up your emotional response versus reading it from their reaction.
Yep. All right.
So I'm not entirely sure, but there might be an application in exam proctoring, especially when people are kind of giving these exams online and whatnot. And in some countries, there are more frauds than in other places. If there are ways to detect some of those from these behavioral analysis and gaze tracking and whatnot.
Yeah.
I'm not super clear how to do it, but I see some combinations emerging here that might be helpful.
Yeah.
Yeah. Yes, for like especially for something like an exam, it will be very interesting to know how somebody is internally, physiologically or emotionally reacting while writing an exam. If they're stressed, they're scared. I mean, of course, we know that someone writing the exam might be scared or might be stressed, or like actually seeing this thing in terms of result might be very good. And I think the human being is just an embodiment of data, like a lot of data, a lot of things happening within us, a lot of our body, we're always in state of emotions, different emotions every day. Being able to capture them would be interesting. That is why we more or less focus on trying to get the internet data of people, and we believe as well that they have a lot of applications from medicine to transportation to sports, focus groups, and all, even games. So yeah, thank you very much.
All right, Pasindu, you have your hand up.
Yeah. Hello, Rose. Great presentation. So I have one question. So I assume at the end you are doing some query to get the results from those memory records.
Yeah.
So did you do any application to identify for a particular query can you identify which input modality contributed most to get the results?
Sorry, can you speak louder? I can't really get you.
Okay, so for a particular query, can you identify which input contributed most to get the result?
Oh, okay. What input I think again all the inputs are really important. Like the speech, whatever you're saying, whatever is being discussed in the meeting is or in the situation is important. Being able to capture that, it gives like a lot of context. Eye tracking, it's more or less again just where your attention is at, where you're focusing, whether your eye is moving up or down, whether you're not paying attention at all. Eye tracking is able to even not going into deep analysis. If you're like watching a movie and somebody else want to know if you actually watch the movie, just to if you had wear the eye tracker, just to look at the result and see if your motion was really on the screen or outside of the screen. For again, I think speech has a lot of input because it gives us a lot of context. The emotivate is just more or less argument to be like, oh, at this point, what was I feeling? What did my body say? More like what was my heartbeat? Was it fast? Was it slow? And then we're able to make meaning from those stuff. So I think speech has the most eye tracking and emotivate, like the physiology, just more or less argument what the person is from the participant, like internally, more like how they responded versus what they hear, and a lot of speech has the most. Let me just say that. Thank you, Pasidu.
All
Yeah,
right.
I think
With that, I'm going to jump in and we'll, before we transition to the third presentation, some of our alumni are here and I want to give them a chance to do their Minute Madness. I will remind everyone that WSDL is for life. So once you're in the group, you get a tattoo and it never goes away. So let me see. We'll start with Alexander. Tell us what you're up to, when you graduated, and your ongoing relationship with WSDL.
Hello, everyone. Can you hear me clearly?
Yep.
Okay.
Yes.
Thank you so much for the invitation. My name is Alexander Nwala. I'm currently an assistant professor of data science, 1 hour away from you at William & Mary. And I graduated from WSDL 2020. And then I went to Indiana for almost 2 years for my postdoc before coming to William & Mary. And currently, my research still involves other different aspects of the web. Currently, I'm focusing on developing methods to detect various forms of social media abuse, detecting bots, detecting coordination. And more recently, we're focusing on using various clues like behavioral change, that's the changes of behaviors to identify suspicious activities. And this will be very important because we've seen that AI systems can now fool us on social media. So using behavioral change could be one of those clues to identify inauthenticity. And then I'm also doing some work with respect to news. And recently we've been trying to identify digital local news deserts. So we proposed this new method of identify local news desert, but this time focusing on digital content. And then with collaborating with Saru to develop a very large longitudinal US local news data set, which we'll be announcing soon at some point. But the idea is to get a snapshot of local news content from all 50 states, a daily snapshot of local news content from all 50 states, newspapers, radio, TV stations. And I'm also collaborating with Dr. Michael and Dr. Weigel with Himarsha on the project on studying how information flows from social media to TV news. So once a member of WSDL, always a member. I've learned a lot. I learned how to go from being a PhD student to being an independent researcher. It's not a natural transition, but having supervisors, having guidance of Dr. Nelson, Dr. Weigel, Dr. Wu, Dr. Sampad, very, very helpful in my transition. So for those of you who are thinking of academia, it's definitely possible to go from PhD to academia. You just and you're a good company because you have the right people. But I'll always be happy to share my experience with you. Thank you.
Excellent. Thank you. And Himarsha's presentation, as Dr. Weigel said, she's batting cleanup, be the last one. So next, Banuka, thanks for joining us.
Hello, thank you. So can everybody hear me?
Yes, thanks.
Okay, yeah. Hi everyone. My name is Blanca. I came to ODU back in 2019. So when the dollar stores were dollar stores, and then what I did was I did my PhD and graduated in 2025 in summer. Then I joined the ODU as a teaching assistant professor. So this is my the first year, the end of first year at the appointment, and in terms of teaching, I'm teaching undergraduate classes and graduate classes, pretty much everything from programming, networks, cybersecurity, and some of graduate classes in data science, like data visualization, data science, and HCI as well. And talking about things, in addition to that, we have been working on a grant. Actually, we got a grant with Dr. Sampath, and it was from Commonwealth Cyber Initiative, CCI, and there we are working on a startup idea. And so what we are basically doing is we are continuing the things we did for my dissertation research, and we are trying to move it in the direction of public displays. So that is the main highlight from my end. And for the project, I'm working with Dr. Sampath, and I have Pasindu, and also we have Emmanuel working on the project as well. Hope everything goes well. And again, nice to be seeing all. Thank you.
All right. Thank you for joining us, and congratulations on the grants. You know, I'm going to ask next that you blog about this, because whenever anybody gives you money, it's a big deal. We have to celebrate it. All right. Dr. Lam, you're the next.
All right. I'm Saud Alam. I work at the Internet Archive as the research lead of the Wayback Machine. Joined ODU in 2009, and I finished my master's and PhD from there. Graduated in 2020, the same year Alex graduated, and I joined Internet Archive a few months before my graduation. So since then, I've been there, and I'm actively involved in research. Some of you here, I'm working with you, Dr. Wu. I'm a co-PI on one of those projects where Rochana and Lamia are working on. Michael, Michelle, Kritika, I've been working with you on the TV news thing. We worked in the past together. So there are a bunch of active relationships with WSDL that are ongoing. A recent bragging right that I kind of earned was being famous in Russia, right? I sent the email to you all. Basically, a research paper we collaborated on with folks from Stanford University and a university from London. And there we try to look at the prevalence of AI-generated content on the web and how it's impacting the web. And that one made some headlines. And in that process, the paper was cited in one of their programs in Russian on a Russian TV. And it was like 23, 24 seconds or something. The paper was on the screen. So our names were flashing on screen basically, and someone was basically doing commentary on that. And how we learned about it was another interesting piece. So Internet Archive does TV archiving. And Himarsha, I don't see her here, but yeah, I mean, she was working with that data set. So we are archiving the TV live stream, saving them as programs and transcribing those, and then translating it. And then someone from the team had like a kind of a alert system set in place, like, hey, if Internet Archive shows up somewhere in the TV news archive, let us know. And that's how we got to know about that piece. So I did not watch the live program, but we have an archive of that, and we can link to that particular segment where you can go watch that with translations. So yeah, that's me. Reach out to me if you want to do any projects that involves Wayback Machine or massive data. Recently, we have also made 2.7 petabytes of Web Archive data public. So that is related to government documents, mostly like all the end of term crawls. When each 4 year when presidential election happens in the US, we try to archive federal government websites before, during, and after elections and inauguration. So that's a massive amount of data that you can use for your research if you want. I'll be happy to help with that.
All right, excellent. Thank you, Sood. Sood's also our hookup for the cool Internet Archive shirt that he's wearing. I've got one or two. I'm sure he's got some extras he'd be able to. I wear them to concerts. Everybody loves the Internet Archive. Everybody wants to say something to you when you wear the shirt. So
there you go.
All right.
I get some of those comments when I go to, like, places like Walmart, Aldi, and places like that, and some people, yeah, like, really.
Yep, it's definitely one of the good guys. Excellent. So let's see. Actually, we just had another person join us before we get started. Justin, you want to give us a little update? Not to put you on the spot.
What, 3 seconds after joining in?
Yeah, just a Minute Madness, who you are, what you've been up to.
Yeah, sounds good. Hey, I'm Justin Brunell. I'm the chief scientist of the software engineering division at the MITRE Corporation. And my role there is I'm responsible for the tech strategy, a lot of the discretionary investment associated with our internal research and development program, and I'm responsible for the internal and external research strategies associated with software for the organization. And we operate multiple federally funded research and development centers focused on solving the government's toughest challenges.
All right, excellent. Thank you. Justin can't hook you up with any cool T-shirts, but he can hook you up with some homebrew beer. So that's even better, right?
Most importantly, that's right.
Yeah. All right, Akshay, I think you're up next.
Hey everyone, can you hear me?
Yes, thank you.
Perfect. I hope you can see my presentation. Just let me know if you cannot.
Got it.
Perfect. Hey everyone, this is Akshay Kolgar Nayak. I'm a PhD candidate being advised by Dr. Vikas Ashok. And today I'll be presenting my work, Contextual Scaffolding and Self-Efficacy, supporting computer skill development among blind learners in India. This full paper was published in the CHI 2026, that is a conference for human factors computing that was held at Barcelona, Spain. So starting off with this, yeah. So why India and why the study? So India is the world's largest home for the world's largest population of visually impaired individuals, which includes nearly 70 million people who are visually impaired. And out of that, at least 5 million individuals are completely or legally blind. Yet, less than 10% of these 5 million individuals, again, this census was conducted in 2011, and this number has significantly increased since then. Out of those 5 million individuals, less than 10% are formally employed. This is contrastingly different compared to the United States and the UK, where at least 44% and 27% of the visually impaired individuals or blind individuals, to be more accurate, are employed. To bridge this gap in employment, the government of India and has started several programs like the Digital India and Skills India to bridge the skills gap. This is accompanied by NGO-run computer training centers, which is where the primary places where BVI individuals first encounter access or physically access to desktop computers as well as screen readers. So to give you more information, a screen reader is an assistive tool that reads aloud digital information, thus making any visual information on the screen accessible to individuals who have difficulty in the vision. But here's the problem about, so there has been a lot of work in inclusive computing education as well in order to make computing concepts and computer navigation more accessible to individuals who are visually impaired. So this includes making IDs accessible and programming concepts accessible as well. But the main problem is that all what we have known and even these technologies, the design of these technologies draw their evidence primarily from global north populations where accessibility frameworks and laws like the ADA are more mature. But in countries like global south countries where the majority of the blind population lives, such frameworks are very nascent or in the early stages. Hence, there is a research gap where there is very little research that examines what actually happens in these resource-constrained and also, more importantly, multicultural contexts and multilingual contexts such as India. There's a gap in understanding how trainers teach computers, screen readers, and how students learn, and what are the complexities where the systems break down. So this research was guided by two questions. The first question examines the trainer's side, where we wanted to understand the curricula that is being used, how trainers actually deliver computer instructions to individuals who are blind or visually impaired, and how do they assess learners, what are the challenges they encounter in this process. The RQ2 shifts towards the learner side, where we understand the backgrounds, the lived experiences of novice BVA learners, things they like, things like how did they went and how did they lose their vision, their prior exposure to technology, the transition phase, and also other systemic factors such as their language abilities, etc. And how do all of these factors shape the way they learn? Critically, this also includes how much they believe in their own ability to succeed, which is core for any learning task, as defined by Bandura, which he puts it under the term self-efficacy, which is nothing but confidence to learn any task. Now, methodology. So in order to understand the computer learning system, we conducted a 4-month contextual inquiry at 2 training sites in India, an urban computer training center in Bangalore, and another rural blind school in Ranebennuru, which follows the standard K-12 curriculum with add-on basic computer instructions. Across both the sites, at the start of the study, we worked with 94 BVA participants, which includes trainees, computer trainers, as well as other instructors such as Braille instructors, language instructors as well. The study had 3 phases. We started with a pre-study interviews, a survey with newly enrolled students and other participants to understand the backgrounds and what kind of expectations they had from these organizations, or why did they join in the first place. And then we spent the next 2 months observing at the beginning of the academic session, and then later at the end of the academic session, where we visited these training centers twice a week, sitting in on the classes for 4 to 5 hours, documenting how trainers taught and how students interacted with the materials and the collaboration between the trainers and the students. At the end of the study, with all the participants that were available at the training centers, we conducted post-study interviews, which also included 23 recent graduates and 8 past trainees. For the data analysis, we used hybrid thematic analysis, which is the most popular methodology in empirical research. We started with inductive open coding, which was grounded in participants' own language, and then mapped these emergent themes from the open coding onto established theories such as Vygotsky's zone of proximal development or Bandura's self-efficacy theory, which was the deductive coding of the entire process. Now, starting with the findings, the first findings points towards the curricula and the pedagogical framework as a whole. The curriculum followed at these training centers followed a curricular framework called the Kionics, which was nothing but a government certification designed for sighted peers. Screen reader training was available, but however was never assessed or certified in a structured manner. This is, if you can look at the code that's been provided, that's something that the trainer said, that the screen reader cannot be certified because in his opinion, it is not meant for the general population, and the government is only responsible for something that's for the common population. The trainers were hired solely for the screen reader proficiency alone. They had no pedagogical or CS background, though they were teaching that. Teachers in such cases usually defaulted to rote demonstration, where they drew from their own experiences, trying to teach the students the shortcuts or the navigational strategies that they built in the applications they trained for. This means that these trainers, a lot of them relied on old MS Word versions, for example, which dated back to 2007 or 2008. When asked why they're not teaching the latest, they said that they simply did not have the training on how to use these new technologies, which pointed us to a fact that they did not develop generalizable navigational skills. Therefore, their learning was very context focused to specific versions of the software that they were trained on, which they just passed on to the new students as well. Next, we talk about the socio-technical factors and self-efficacy. Most trainees came from economically disadvantaged backgrounds. Due to their continued non-employment, a majority of them held below poverty line cards. For them, training center was their first, like I said, the first real encounter with the desktop computers. Late blind learners faced an additional challenge as well. They received no transitional support. They were grouped with congenitally blind peers and expected to adapt to the same audio-based screen reader navigation immediately as their congenitally blind peers. Despite having spent a lot of their life with complete or partial vision, this transitional support was completely ignored. Most importantly, a lot of these users who had no idea on how to use a desktop screen reader were very well versed in how to use a mobile screen reader, because as they learned navigational strategies to use these devices on a daily basis. However, the navigational strategies or fluency when it comes to desktop or navigating a desktop with physical keyboard was not up to the mark. Their families were very supportive, but lacked any knowledge of screen reader or accessible computing in order to support them. Overall, in the society, they celebrated any kind of a respectful office job that they could get without understanding or exploring the full potential of how a screen reader education in early years can help develop greater computing proficiency or even advanced computer skills, how it's done in more developed countries, which could lead pathways to more advanced career opportunities in the ICT industry. Yet, despite all of these issues, all of our participants seemed really motivated They held learning computers as a badge of pride. A participant described how even the society around them often reacted with surprise that a blind person could operate with a computer, which points to both a motivation and the lack of systemic knowledge in order to train them. In terms of learning challenges, learners faced a compounded cognitive load. They were simultaneously learning the QWERTY keyboard layout itself at the beginning, English terminology, screen reader shortcut, and even in most cases, multilingual typing with in-script mappings, and as well as building mental models of the software that they have never seen all together at once. So this multifaceted learning experience was cognitively challenging for these learners. When they hit errors, they lack the vocabulary to even describe what went wrong. Documentations that were provided with these screen readers were either too technical, uh, or even in many cases, if they were trying to access or learn something that is not developed for visually impaired individuals, they assumed visual context, which made it more difficult for them to learn and acquire these technologies. Peer help was always available. However, this was very ambiguous. Students got different shortcut sequences from the same task from different peers, making the learning way more confusing and also limiting them naturally to the knowledge that's available from their peers. Most critically, the learning stopped at graduation. Without employment, students returned home, lost physical access to computers, and the skills eroded over time. As building navigational strategies and generalizing screen reader skills require constant practice and access to computers, therefore. Now, drawing on these findings, we discuss how we draw parallel between how inclusive training happens in resourceful constraints and resourceful areas and resource constraint contexts. A few of these include trainers have pedagogical credentials in the global north. AT exposure is scaffolded across years, starting from early K-12 education using multimodal methods, including tangible and haptic feedback and supplemented audio. And even many institutions such as HKNC STEAM provide post-training rehabilitation pipelines, which help sustain computer and navigational skills along with support efforts for employment. In India, we found the opposite at a lot of these levels. Cited certification exams, for example, as I explained earlier, trainers without pedagogical training, everything was compressed into one overwhelming year at their adult phase for them to acquire audio-based interactions and no support after graduation at all. So this points to a fact that simply importing a global technology and a curriculum just doesn't work in resource constrained settings. And the sheer diversity of languages, the schooling backgrounds, and the baseline digital exposure demands a locally adaptable solution that can help these learners truly acquire these technologies. Now, a core problem is that the current pedagogy also treats learners as uniform blind identity, which also ignores onset differences in their lived experiences, onset of visual impairments, language, and even the prior exposure to technology as a whole. In order to mitigate these, we propose three recommendations. The first is to introduce concepts using their native language and familiar terminologies, using some form of a transition from their current experiences and knowledge to screen reader or English specific commands. This helps reduce extraneous cognitive load, and learners will be able to focus more on their intrinsic load of learning computer concepts and screen readers. Second, it is important that we create assistive learner profiles grounded in their own lived experiences and knowledge. A blind learner, for example, needs readaptation scaffolds and more a different learning strategy than someone who is born with blindness and who is used to the one-dimensional audio-based navigation from early on. Therefore, there is some kind of a contextually rooted personalized education that is required to build their confidence over time in the learning process itself. Third, it is very, very essential to treat trainers as the trainees themselves. It is important to equip these trainers through training of trainers program, a pedagogical mirror that builds conceptual knowledge of computers and screen readers and helps them stay with the latest technologies over time. Drawing on this, we propose design guidelines for educational technologies that supports inclusive computer education or learning experiences for BVI individuals in resource-constrained settings. The first starts off with trainers are usually overextended and cannot provide individualized instruction that every trainee demands. Hence, the current emergent technologies in AI-driven tools can help maintain and build these learner profiles and help patiently adapt scaffolding in real time that draws on their interaction traces and error patterns and response time over time. Students in a study also fear breaking computers during exploration. Audio-based sandbox simulations can also provide a safe, consequence-free environment to practice commands without any such fears. Screen reader output is unfamiliar in English, and learning resources assume visual context, so a multilingual LLM coach could shadow and interpret screen reader output for them in a language that is familiar to them and use terminologies that they can better understand. And this learning ecosystem should also be able to support trainers themselves. And also, one of the most important factors while introducing AI in such educational contexts, which even I advocate for while also reviewing other works, is that when we design an AI system or an AI training system in such a sensitive context, it is very important that we audit these systems for ableist and ocular-centric biases that they encode, similar to our cited world. LLMs, once again, are trained on highly visual data, as well as data that draws evidence from the global north and resource-rich context, which might simply not translate as is in contexts that they're not developed for. Hence, participatory design and drawing on evidence from these contexts is very much necessary in designing these tools. Limitations, our study had a few limitations. Our participants were from a single region in the state of Karnataka. And however, India varies enormously across states where language and context change in a few hundred miles drastically. Hence, it is a broader study across the country and that expands to other global south countries around, such as Pakistan, Bangladesh, Kenya, are very much necessary in order to validate for the external validity of the research. And another limitation of the study was also that majority of our participants were fully blind. So the experiences of those individuals who have some form of a low vision or residual vision has not been accounted for. Hence, hence our future work should also account for the experiences of these individuals who do not necessarily need screen readers, but can use screen magnifier or other assistive technologies to navigate digital information. And future work will address these. Yeah, so overall, this work study examines the computer learning experiences of BVI individuals in the learning in the global south, countries such as India, where resource constraints dictate that we need a contextually rooted scaffolding for them to learn and acquire the self-efficacy for the learning process. Yeah, thank you, everyone.
All right, excellent. Thank you, Akshay. Questions for him? Questions? Let's see. John Shirley, you have a question? So you talked about this being, you're applying this in a region in India. The idea, I guess, is that it is applicable to the global south. What is your intuition for what things will not extrapolate from your current experimental region to other areas in the global south? I know you haven't formally, I guess, tested it. Yeah, surely you have an intuition.
Yeah, well, that is a very interesting question. So the region in India follows one curriculum, like I said, the curriculum that was tested for is Kionics, which was a government certified certification program, and they just added screen reader to that and as an add-on. However, the curriculum itself might differ in many other regions. We don't know if they're even adopting the same curriculum or adding screen readers on that, or if it's done very differently in their regions. And so how does it translate to these frameworks or students who have access to, who have been brought up in these, their educational frameworks? So what are their experiences? What are their learning needs? And how do we support that? I think it's the one thing that will obviously change. However, a lot of the work might, and like I said, if we are planning to provide uh, AI support for such teams in such contexts that are different, I think we need to understand their societies and provide support in the manner that they understand.
And would it be applicable for, say, Native American populations? I don't know how big the BVI population is within that population. But my limited understanding is there are significant cultural differences, even though geographically it's in the continental United States.
I do think a lot of the research that that this work supports and the future work that supports with these tech tools, I think will be applicable to a lot of global South countries. And I think there's a lot to learn even for the global North countries. If we can design a system that can personalize education to an individual, that's something that I think is globally applicable. Although there has to be a little bit of few knobs that needs to be fine-tuned for those contexts, but I think a lot of what we find might be applicable for everyone else.
Okay, excellent. Thank you. Any other
Thank you.
questions for Akshay?
Yeah, I'll toss one out there. So you mentioned a couple of things like IDEs. What do the automated accessibility tests say about the IDEs, and would that have applicability in addressing any of their shortcomings?
We did not use automated accessibility testing I did not conduct that. But however, we did have a publication in the TPDL last year, where we assessed automatic guidelines and tested a lot of the websites that are available. So most of these pass the accessibility test because in the United States, at least, the law requires us to pass the ADA guidelines and make sure the WCAG guidelines are followed before they're developing any public websites. So that just pass out. And so most of these IDs are made accessible right now. There are also alternative solutions like the project, like StructJump. I think there was Project Torino by Microsoft. All of these, which makes IDE accessible, trying to give a sequential access to programming tasks, make sure they can understand code better. However, there's also an interesting, I'm just going off on a tangent here, but however, there's also an interesting conversation that we propose that accessibility doesn't mean usability. Just because we just add alt text to an image or make things accessible doesn't mean the blind person can use it. For example, just give you a very simple example. A very cluttered website has all of the information, but it makes it extremely exhausting for us visually sighted people to even use it. But now let's say we provide one-dimensional access where forming that mental structure of the entire website becomes, even though it's accessible, it's very, very tedious for them. So that's what we advocate for, usability, make things usable. Now, how do you automatically test that? I think that's a very, very interesting, that's open question in the software engineering community. How do you automatically test a website for usability? Because usability testing is very, very subjective. Although we have questionnaire like SUS, NASA, TLX, which makes it less subjective, I think a lot of the usability test is subjective. But the growing interest in LLMs is that they're trying to design digital twins, which can replicate a lot of these user studies. And hopefully we can build personas of users which can surface this, at least the basic set of usability studies in these ones.
Okay, yeah, super useful. Thank you.
Thank you.
All right, excellent. With that, we are fortunate enough to have two more alumni with us. So I will ask Yusif to give us an update on where you are, what you're doing, your ongoing relationship with WSDL.
All right. Can you hear and see, Dr. Nasa?
Yep.
All right. So hey everyone. So I'm Yasit. I was there in WSDL until 2024, and that's when I graduated. But I officially took the graduation this year, so it's been a while. So it is good to see you all. So just to give an update from my side, I'm currently working at Georgia Tech, basically helping them build the cyber infrastructure. So initially, like at WSDL, I was building a platform for streaming data analysis, and they were interested in the work that we did, basically modeling the sensory data, things like that. And now like their focus is building HPC scale systems. So that's where like I come in, I build sort of like the systems infrastructure for them, for researchers to use the software and build things with AI. And on the side, I'm doing a startup as well, a user research startup, which I think Akshay's work is kind of like made me thinking there might be some good things to do there. So basically building AI personas of different kinds of users, different roles in companies, and putting them out to test software and ask questions like, hey, does this model feel right on the left or the right? Or like, how do you feel on the color and the placement of things? So that's sort of like a high level update. And again, good to see you, everybody.
All right, thank you. And let me see, Dr. Kelly, who just recently gave Dr. Weigel and I academic grandchildren. Congrats to you on graduating your first PhD students.
Yeah, thanks for that, Dr. Michael. Yeah, so I was a Whistler. I graduated in 2019. My research focus was on personal and private web archives. A lot of my research is kind of stemmed off of that as well. We've done a bit with regard to personalization, trying to preserve the sort of web that was truer to how it was rather than what the robots see on there. Just graduated two of my PhD students after being at Drexel University for about 6 years now, and researching some other topics that are sort of beyond WSDL, like semantic evolution, trying to kind of map some of the temporal negotiation into other dimensions, and some privacy and ethics things with regard to AI. So it's kind of expanded out into that. So glad to see, and I like to see the evolution of WSDL as it is now.
All right, excellent. And if I've missed any alumni, just let me know, but I think that covers everybody. And next up, I think we have Rochana.
Yes.
All right.
Can you
Got it.
see the screen?
Excellent. Yep. Thank you.
Hello everyone, I'm Rochana Obadage, a PhD student advised by Dr. Jianwu. And in this presentation, I'm going to introduce our dataset, CC30K, a citation context dataset for reproducibility-oriented sentiment analysis. As Dr. Wu mentioned, this work was published as a long paper in WSDL 2025. One of the foundational aspects of research in machine learning and artificial intelligence is the ability to reproduce results. Reproducibility is essential because it ensures that findings are reliable, verifiable, and can be built upon by other researchers. Without reproducibility, we cannot be confident that our results are accurate or that they can be trusted. Despite its importance, achieving reproducibility in ML and AI research presents several challenges, including infrastructure constraints, inadequate documentation, the use of proprietary data sets, and the inherent complexities of AI and ML research. As you all understand, directly reproducing results at a large scale is often infeasible. This difficulty arises due to the extensive resources required, including computational power and time. Basically, we can't manually reproduce every ML paper published each year. To address this gap, we propose a novel solution investigating the use of citation context as indicators of reproducibility. The basic idea here is that if a paper has already been published and cited by others, the way it is discussed in those citations can sometimes carry a sentiment, and that sentiment may actually signal whether the original paper's results were reproducible or replicable. To study this idea, we need to build a data set with two key components. First, machine learning papers that already have reproducibility labels. And second, the citation context of those papers, each labeled with reproducibility-oriented sentiment. So in this work, we are introducing a large-scale dataset that addresses these two key components. Before moving further, let me clarify the terminology used in our study. Beginning with citation context, it refers to the text surrounding a citation in a research paper. Next, we have original studies. These are the foundational research papers or findings that serve as targets for reproduction. Then cited papers are the papers that reference or cite the original studies. Next, we have reproducibility studies. These are dedicated attempts to duplicate the results of a previous study. Finally, we have the reproducibility-oriented sentiment, which refers to the type of sentiment expressed in a citation context that specifically targets reproducibility. When we look at sentiment analysis and citation analysis separately, we see that many data sets exist already, and many of them are much larger than ours. However, their goals and problem settings differ from what we are trying to address. Our work basically targets reproducibility-oriented sentiment, while existing data sets mainly capture general sentiment or citation function. Because of these gaps, our CC30K dataset is the first large-scale dataset specifically built to capture reproducibility-oriented sentiment in scientific literature. Let me walk you through with our data production pipeline. First, we collected 145 reproducibility studies from existing data sources. Second, we collected metadata for the original studies that were assessed in those reproducibility studies. Third, we collected citation contexts from citing papers that cited those original studies. From about more than 13,000 citing papers, we collected about 41,000 citation contexts. Fourth, we did crowdsourcing for reproducibility-oriented sentiment labeling. Fifth, we selected 1% of the crowdsourced data, crowdsourced labels, and validated them. Due to the significant imbalance we saw for negative category, when we were doing the crowdsourcing, as the sixth step, we did negative augmentation to balance the dataset. Looking at the data sources, we gathered our data from several prominent venues, including MLRC, NeuralPS, ICLR, spanning from 2019 to 2023. Because the majority of papers selected from above venues were successfully reproduced, we supplemented our dataset with 16 reproducibility studies from table structure recognition methods by Jayanetti, which had 11 unsuccessful reproducibility studies. Before starting the crowdsourcing process, first we had to solve an important problem, that is how to ensure that crowd workers know which cited paper to evaluate when a citation context contains multiple citations within the single context. For APA-like citations, this was manageable because we could append the first author's last name to the labeling item itself. However, when context included combinations of numeric citation marks, like the one shown in this item E at the first table, it became impossible for crowd workers to know or reliably identify the correct cited paper. So we analyzed all citation contexts and identified 3 scenarios where a cited paper can be unambiguously determined. As shown in this bottom table, we kept only these clear cases and removed citation context like item E. As a result, the dataset size dropped from 41,000 to 25,000. Now, let me explain how we defined our 3 reproducibility-oriented sentiment categories. Positive ROS means that the context hints about reproducibility. This includes successful reuse of data, code, or concepts, and terms like reproduce, replicate, or repeat experiments. As you can see in the example at the left side, the context from the citing paper mentions about using the code from cited paper Tian et al., which shows successful reuse. So it is labeled positive. Negative ROS means that the context hints about irreproducibility, and neutral ROS refers to citations that do not provide any signal about reproducibility. For the crowdsourcing task on Amazon Mechanical Turk, we built a custom graphical user interface using crowd HTML elements. The screenshot here shows exactly what the workers saw. In the green box, they weaved the citation context along with some additional details we added. On the right side, they selected one of the 3 sentiment categories we provided, and they clicked submit to move to the next labeling item. So because the annotators were an unseen audience, quality control was essential. We used a 2-stage selection process to build a qualified annotator pool. For stage 1, we created a small ground truth set containing 20 citation contexts with expert labels. Then we broadly recruited MTech masters and posted several batches, each time excluding the workers who already participated in our pilot study. In total, we had 138 workers who completed the initial task. At the second stage, we conducted a performance-based selection. Workers had to meet the 3 criteria listed here. Based on these criteria, we selected 16 qualified workers for our final actual labeling task. Basically, we used a Mechanical Turk with a structured strategy. Each citation context was labeled by 3 independent workers, and we applied majority voting to determine the final label. The entire process took us about 27 days, and our total budget was slightly more than $3,000. On the right, as you can see, the label distribution after majority voting, it clearly shows that the negative class is heavily underrepresented. To validate our crowdsourced labels, we conducted a separate quality assessment. We used stratified sampling and manually verified about 1% of the data set. And that was 244 citation contexts in total. So there we obtained a 94% validation accuracy. And as we have mentioned, after crowdsourcing, we noticed that the negative class was heavily underrepresented. So we used a semi-supervised approach to augment negative context. First, we collected computer science papers published after the year 2016 from Semantic Scholar research corpus. That gave us about 1 million papers. And from that, we randomly selected about 5%, about 21,000 papers. Second, we downloaded the citation context, all the citation contexts for all those selected papers from the Semantic Scholar Graph API. And there we collected about almost 700,000 citation contexts in total. Then after doing this citation context collection, we fine-tuned 5 reproducibility-oriented sentiment classifiers using popular transform models, using majority voting from the on symbol. We identified about 43,000 negative contexts. After the ensemble classifier identified these 43,000 potential negative contexts, we needed to verify them because even the ensemble classifier was not perfect. So it had about 80% F1 score. So we manually went through more than 5,000 contexts of those 43,000, and we identified 1,055 actually negative contexts, and we selected them to train another binary set of binary classifiers to distinguish the actual negative from not negatives. These are the listed classifiers are the ones we used, and using the best model Roberta, we filtered out remaining machine labeled contexts down to about 12,000 actual negatives. In our CC30K dataset, each record has 37 columns of metadata from 4 sources. First, the crowdsourcing process itself. Then we have the reproducibility study, the original paper or the cited paper, and the citing paper. And last, we have a category label to indicate from which approach the label comes from, whether it is from crowdsourcing or augmentation. So this is the final composition of our CC30K dataset. From all 3 approaches, we now have a total about 5,000 negatives, which is in balance with the positive portion. And previously it was about 1%, and we could increase that to about 16% using our secondary approaches. These are the citation patterns we found throughout our data set. I will quickly go through this. And to demonstrate the practical value of CC30K, we fine-tuned several large language models on our dataset for the specific task of reproducibility-oriented sentiment classification. We evaluated all these models on the same 244 sample, which we used to verify our outsource labels. We experimented with 2 open source models, Qwen 1.57 billion and Llama 3 8 billion, and also one commercial model, GPT-4o, retrieval augmented generation. For each model, we tested 8 settings, the base model, and fine-tuning with 3 data sizes under both zero-shot and few-shot prompting. That's how we had these 8 settings for each model. Across many settings, we see that fine-tuning on CC30K outperforms the base model inference, but the degree of improvement varies depending on the model prompting strategy and the amount of fine-tuning there. As a summary, we introduced CC30K, a large-scale dataset containing about 30,000 citation contexts, each labeled for their ROS reproducibility sentiment. That was our main contribution in this work, and we also validated our data set. And as future work, first we plan to develop an uncertainty-aware reproducibility assessment framework based on citation evidence. Second, we aim to identify the minimum amount of citation evidence needed to reliably determine if a paper is reproducible or not. And third, we will investigate how reproducibility signals vary across venues, publication years, and the citation functions. Finally, we plan to integrate ROS label citation context into the citation graphs. And yeah, that concludes my presentation. Thank you very much for your attention.
Excellent. Thank you. Questions for Rochana? Who wants to go first? So, Rochana, I'm not sure how in scope this is for what you're doing, but listening to you talk, it made me think. Is there a security element to automating the reproducibility aspect of this, right? So Goodhart's law, Campbell's law, basically, when people become aware that they're being evaluated on some measure, right, they start falsifying the data. So applying this technique going backwards in time, we can assess the reproducibility. But if I were dedicated to trying to increase my reproducibility score or fudge my reproducibility score, what techniques could a black hat use to score well, even though, given that you've published your method or similar methods? Does that make sense?
Yes, yeah, actually, that's a really important aspect to consider. We still haven't thought about that, but so one thing I can say is basically we might be able to rely on the prominent venues or established journals and the publishers to obtain this citation context instead of obtaining all the citations from every research article or scholarly paper. That might limit this issue for a certain point, but I understand that's really important concern to consider.
Right, yeah. And yeah, it'd be interesting to think, and again, outside the scope of what you're working on, but for for your PhD students, right? Given that these methods are published and there are people, during my time at the ACM Publications Board, they deal with ethics violations, and I was shocked to see large-scale fraud in the publishing and the academic community. Large networks, groups, pockets of people all collaborating to inflate their numbers. So it's not really that far-fetched, right? And if people wanted to score well on these measures, and they already have sort of these fraudulent citation schemes, reviewing schemes, so forth, what techniques would they apply to game this system as well for citation context and reproducibility?
Yes, yeah, we might have to think about this further. Basically, we kind of, when we were starting with this project, we kind of thought this would be an alternative, but not completely substitute the manual reproduction. But yes, we.
Well, like I said, that's a project for your PhD students, right? So, any questions for Rochana? All right. If not, we'll ask Himarsha to take us home with the last presentation. All right. Got it.
Great. Are you able to hear me also?
Yep. Good.
Great.
Thank you.
Good evening, everyone. So my name is Himarsha Jayanetti, and today I'll present my research on infrastructure for tracking information flow from social media to US TV news. My advisor is Dr. Michelle Weigel, with co-advising from Dr. Michael Nelson, and WSDL alumni, Doctors Alexander Nawala in data science at William and Mary, and particularly for this project, Dr. Saud Alam at the Internet Archive. Now, on the left, You can see a post from the real Donald Trump account on Truth Social, and on the right, the same post is featured on the Rachel Maddow Show, airing weeknights at 9 p.m. on MSNBC, or MS Now currently. At the time, Truth Social had approximately 2 million monthly active users, while the Rachel Maddow Show attracted around 3.9 million viewers. This means that the potential audience for this particular post nearly doubles when it appears on television. This pattern extends beyond this one example, particularly for any tweet, Instagram post, or TikTok video that gets featured in mainstream media. It can yield an additional reach that goes beyond the traditional engagement metrics such as likes or shares. So this motivated us to take a closer look at how social media content is represented and appear within US TV news broadcast. The median age of users on social media platforms like Instagram and TikTok falls between 20 to 34 years. And in contrast, the viewers of TV channels such as MSNBC and CNN have a median age ranging from 67 to 70 years. In other words, like I always say, grandparents tend to watch TV while the younger generations, they scroll on social media. So this generational divide not only broadens the reach of social media content when it gets featured on TV news, but it also exposes it to a substantially different demographic. So this difference in the audience further motivated us to study the social media content that get referenced in TV news. Now, while it's clear that the information does flow from social media to TV news, the exact nature of this flow remains unclear. So that's what inspired our research questions. First one being, what are the various representations of social media references in US TV news? Secondly, how can we design machine learning and AI models to detect these social media representations in US TV news? And thirdly, how can we model and classify the context in which social media is referenced in US TV news? Now, in order to achieve this goal, we use past TV news broadcast data from the Internet Archive's TV News Archive, and we found out that the social media is represented in TV news in several distinct forms. First, there is on-screen text where social media handles or platform names or hashtags, they are displayed on the TV news screen itself. So we can use OCR techniques to extract those texts. Secondly, there are verbal mentions where the hosts or the guest refer to social media content during the news segment. These can be extracted or accessed through closed captions. Thirdly, there are visual objects such as the platform logos and post screenshots. But in reality, like in most of the cases, all these different types of representations, they don't appear in isolation. It's mostly a combination of these representations. Now, I see that many of you attended my PhD proposal defense a couple of months ago, where I discussed these research questions in much greater detail. Today, I'll be focusing on visual representations of social media content in TV news, specifically logos and post screenshots using LLMs. Now, during our study, we found out that the logos can be a huge clue for social media content in TV news. But that's not always the case. As shown in this example on the left, maybe there is no visual or visible logo at all. Or you may have two logos at once, as shown on the example on the right, because this is a screenshot of X posted on Instagram, which is featured on TV news. This can be confusing when trying to detect and correctly attribute the source. Even with the logos, we know that the platform logos, they evolve over time, and you can see how the Twitter logo evolved over time. And also the platforms, they have their official logo versions, and they recommend people to use these official versions downloaded from their website. However, people often don't maintain the visual integrity with the official logos. So for example, a television network may use any one of these modified TikTok logos, and these modifications can also complicate logo detection on screen. For our data set, we sampled episodes from 1 day per year between 2020 and 2024, resulting in 36 primetime news episodes after filtering out the documentaries or special programs. We then manually annotated each clip or each frame for social media references. The logo detection, logo and screenshot detection pipeline is shown here on the screen, and we use TV news frames sampled at 1 frame per second as the input. Then we applied image hashing-based deduplication to retain the representative frames and then passed them along with our prompt to the GPT-4o model. We iteratively developed 7 different prompt versions, and the model predictions indicated that whether there is a presence of a social media logo or post screenshot, along with the platform name and a confidence score. So we first evaluated it on a single episode and then scaled it across the 36 different episodes. We reduced the redundant frames using the perceptual hashing by grouping visually similar frames based on the Hamming distance. So for each group, we kept a single representative frame. And as you can see here on the example, consecutive frames from 136th second to the 141st second, they were grouped together because they look visually similar and was represented by a single frame. We named it accordingly, like from 136 to 141 to preserve the original time range. So similarly, the frames going forward from 142nd to 154th were also grouped into another representative frame. Then this slide shows it's an abstracted version of a final prompt, which we used with the GPT-4o. We explicitly defined what should and should not be considered a social media logo or a post screenshot. For example, for logos, we only focus on detecting official platform logos while excluding text, generic shapes, and TV channel graphics, which may look like the logos. For post screenshots, we only mark them as valid if there is clear evidence that this is an actual social media post, not just any interface elements or any partial cues. We also restricted the detection to a predefined set of social media platforms rather than asking the model to identify any platform in general. Finally, the model was prompted to produce a simple output, just like a yes or no decision, confidence score, and the platform that it detected. We built a gold standard data set by labeling every 1 second frame that contains a social media logo or a post screenshot or both, along with the corresponding platform. So for example, in a frame from CNN Tonight with Don Lemon, the file name ending in 136.jpg corresponds to the 136 second, and in that frame, we were able to see both a Twitter logo and a Twitter post screenshot. We evaluated our logo and screenshot detection results using the gold standard data set, and there were multiple prompt versions that we tested, and the results shown here are corresponding to the final configuration, which is the prompt version 7. For logo detection, the overall F1 score ranged from about 0.5 to 0.9 across the channels. Our model performed the best on MSNBC data with a best balance of precision and recall. For post screenshot detection, the F1 scores range from 0.4 to 0.9 across the 3 channels. Again, the model did best on MSNBC data. I have to mention here that in our work, we consider recall to be more critical than precision, since our goal here is to capture as many social media references as possible in the TV news. At the same time, we can improve the precision in later stages by using additional signals such as closed captions and textual mentions from the OCR text. As you can see here, Fox News had the lowest post screenshot detection, like F1 score, and it indicated many false positives. Since the proposal defense, we investigated a little bit into it and found out that one major source of these false positives were due to content from video-based platforms such as TikTok and also occasionally like YouTube. This exposed an ambiguity in our definition of a social media post because while when labeling, our annotations focused on static image-based post, and video content often contains these interface elements like the TikTok logo or like a username or handles that may visually resemble post screenshots. So the examples shown here is a TikTok video sequence from January 23rd episode of One Nation with Brian Kilmeade. Although the frames are not labeled as post screenshots in our gold standard, the model frequently classified them as TikTok posts. So to further investigate this effect, we repeated this evaluation by removing the TikTok and YouTube content, and the performance improved across all the networks, but the biggest improvement was on Fox News. For example, the logo detection F1 score increased from 0.69 to 0.76, and the post screenshot F1 score improved substantially from 0.39 to 0.72. There was no change in MSNBC's performance because there were no TikTok or YouTube content that was present in our sample for MSNBC. So that's why it performed, the model performed the best on MSNBC all the time. Overall, across all the settings that we did, the recall remained high, indicating that the model was effective at identifying the candidate social media content, and most errors were due to false positives rather than missed detection. So overall, our findings demonstrated that the multimodal LLMs, they can effectively identify visual social media content in large-scale TV news archives. And at the same time, it highlighted the importance of the annotation design as well as the dataset composition in evaluating model performance. While the results are promising, there is still considerable future work, and our work lays the foundation for larger research agenda, including improvements to detection performance, evaluation of open source models, multimodal alignment of textual signals along with the visual signals, and better handling of video-based social media content. And as the end goal, for social media references that appears in broadcast, we want to identify when it occurred, which platform was involved, and how it was represented, whether through logos, screenshots, or other textual mentions. And we want to capture all that information in a machine-readable event record like this. Yeah, that brings to the end of my presentation. And to summarize, we developed a multimodal LLM-based framework for detecting social media content in TV news archives. And our results highlighted both the potential of LLMs and the importance of carefully defining social media posts for video-based social media platforms. And looking ahead, this framework can serve as a key building block for large-scale analysis of information flow from social media into TV news. Before I end the presentation, I would also like to take a moment to acknowledge that this work was conducted during summer 2025 as a Google Summer of Code contributor. So I sincerely thank the Internet Archive for this opportunity and support, and I'm especially grateful to my mentor, Dr. Saud Alam, for his guidance throughout this project. So that concludes my presentation. Thank you, and I'm happy to take any questions you have.
Excellent. Thank you. Questions for Himarsha? Who has questions? Who wants to go first? So, Himarsha, you brought up a really interesting idea there with the Instagram with the screenshots. So I don't know. I mean, Taranum is still here, right? But this also suggests that there could be an overlap, right? Because that's arguably both things at once, even though it's ambiguous for detection. Maybe the idea is that it's not binary, that we're only showing one thing at a time. Now that's kind of, I guess, an advanced, topic, but that does suggest that it could be expanded to be overlapping or non-binary or something like that.
Yes, that's true.
I wonder, I know we haven't measured it, but do you have a gut feel for how often this happens?
Uh, I'm not really sure. Yeah.
Anyway, that would be something for perhaps Toronto to look at, right? And the presence of two logos might help establish like a frequency of how often these things co-appear, or screenshot of one platform pasted on another.
Yeah, that's that's a part of my research question for my dissertation proposal, measuring the frequency, how often we see a screenshot of different social media posts on different other social media platforms.
Yeah, this is the only example I saw in our data set. So from 36 episodes, one example, but I'm pretty sure like cross-posting happens more often than we see or we saw in the example.
All right, let's see. Dr. Kelly has his hand up.
Yeah, I've got a question. So this is interesting work, and I'm wondering if through extracting the posts through the video feeds, if you're able to do any validation as to whether those posts are still present on the live web or the live platforms.
Yeah, that would be cool, right?
Yeah, for that we would have to like attribute it just by using the elements that are on the screen. We would have to figure out since we don't know the URL, that would be the hard part. Maybe like a image search or something like that.
So this would go again back to Toronto's work.
Yeah.
where we're trying to determine attribution of a screenshot of a post, right? In this case, it's not really, I mean, it's kind of a screenshot. It's a TV screenshot. And presumably, if it's on a regular news, it's not fake, right? I guess it could still be a joke or satire or something like that. But I mean, most of the procedure for checking and discovering it in the archive would probably be the same. Like 80, 90% the same of what you're doing, 80% maybe. But yeah, that's really cool. That's something that we hadn't really thought of, is applying it to Himarsha's pipeline. Starting with, unless it's, humor, satire, it's probably true, but is it still on the web? Can we discover it?
So one path forward for that would be a little difficult to scale, is to full text search index some of these resources in Wayback Machine, for example. Then text from this screen can be used to find potential candidate URLs and then go from there. Kind of building the index first and then trying to look into that. The problem is these large platforms of social media, they are either extremely challenging to archive, or if we are blessed and we can archive things, it's not very practical for us to make those things very accessible, very searchable. And and we start from archiving those the next day. Um, but if there was some kind of signal, like as we go along and identify URLs or the material that is cited on TV, and if you can find out related pages or URLs, it will actually be a good signal for us to create a virtual collections of those URLs and full text search index those. Because if something made it to TV, it is important enough that we be able to search that in the future, right? Now, knowing which ones those are will be kind of the challenging side, I guess, in this case.
Yeah, no, I mean, I think we should take all of, at least for Twitter, because that's what Taranum's pipeline's built up right now. We should take all of Himarsha's tweet images and send them through Taranum's tool, because it uses, I mean, if these things haven't been deleted, and most of them probably haven't, she can leverage the live web to find it, even if it hasn't been.
Yeah, and our process also involves something what so said about we check through, the candidate URLs to find, at least some relevant to the screenshot of the tweet that we can find and do like a text similarity sort of score, to prove that any sort of evidence for that particular screenshot.
That would be really good, I think, and very important metadata to add to the output of the data set. So if somebody uses the system and they want to see it on the live web and do some more digging, at least having the potential URLs would be nice.
Also, do we have any study on how long does it take for a viral social media post or something to make it to TV? Is it like a day or a week or 2 years later or something like that, right? Kind of seeing the peak there of that distribution will be interesting as well.
Yeah, that would be interesting. I wonder the overlap between things that go viral and things that show up on Talking Heads news program. And it might actually be low, but I mean, not zero for sure, but might be low.
Marsha, write this down as something somebody can do once your dissertation is done.
Yeah.
Right? That's a use case of your tool.
Yeah.
Exactly. That's what your PhD students work on.
Yeah. Because when I looked into that, I found mostly those viral posts, they are on like blogs or something. People accumulate them. Okay, this went viral, but it's on a blog or somewhere on the TV news channels blog, rather than them, bringing it up on TV. I have seen that, but this is a good point to keep in mind.
It doesn't have to be viral, by the way. Sometimes there are non-viral stuff that also makes it to TV.
Yeah.
And kind of, seeing the gap, like when it was first time said, and so if you go back to the Egyptian revolution thing, there was like a post on Twitter which led to such a big thing, right? And like, when was the first time it appeared on TV? You can pin that point, and you already know the time of that tweet, and you can calculate the delta from there. That's one example. There are many recent ones.
Yeah, and also to add to what we discussed earlier about the credibility, like when something goes on TV, people consider it to be more credible. There are studies on that as well. And there was one instance, I think, where people would talk about a fake news going on TV. So that even if they show it, it's a fake news. If we know the context around it, we can detect it as a fake news. But otherwise,
that's the whole Kate Starbird
yeah.
and others. But studying this pipeline from people tweeting, social media to blogging to news, and then it becomes more credible as it climbs this platform ladder.
Yeah.
so a few years ago, an Indian newspaper used to have a section where they would basically um, add like a made-up news that will have like some kind of sensationalization, but it was like known, like, okay, this is kind of a satire part of the news outlet, but it's intentionally noted that this is kind of, hey, this is for a joke purpose, basically, and came up with this kind of, made-up news. That was then translated and included in a Pakistani newspaper as a serious news. They did not pay attention to that kind of note in the corner, like this is a joke.
Right. Right. I mean, this happens all the time. People, especially from other countries, get confused about onion articles or similar, whether or not they're real or and that goes both ways, right? Of who knows what we're reading from, China, North Korea, and what is satire there. I'm assuming exists. So Lawrence has had his hand up for a little bit. Lawrence?
Yeah, thank you, Himarsha. Good presentation. So you're talking about the transition from when a news or something went viral to it going to the news media or like the TV. I think another thing to look at it's more like podcasts. I don't know if you more or less already cover it already. Because these days like some like really popular podcasts, they have more viewers than even the TV stations themselves. So and then some that I do listen to where when something went viral, the podcasts they definitely they cover it first even before it goes to the news media. So looking at maybe how fast it went from just the viral clip to the podcast, then to the TV, I think that might be an interesting trajectory to look at as well.
Thank you.
Thank you.
So this phenomena happens in other medias as well, right? Like you said, podcast and people something that's posted on social media gets cross-posted on a different social media, or it may be in newspaper also we have seen, or any online media like blogs or online news articles. So, and podcast is something that I didn't think of, but we have seen examples of that as well. But the focus is working on TV news, but it's a good side project, or like Dr. Nelson said, future project with future students.
Yeah, thank you.
Thanks for the idea.
Excellent. And with that, I think we're done. If you have any other further questions or comments or project ideas, please contact the people that gave the presentation. I think we've had some really cool ideas pop up here. I'd like to thank Himarsha, Rochana, Akshay, Lawrence, and Brian for presenting their work here today. I'd like to thank faculty for joining us, but especially I'd like to thank the alumni for taking time out of their day to show up. Really appreciate it that they get a chance to return and demonstrate to the students there is life on the other side there. It's big. Really appreciate you guys. Again, WSDL is for life. Sue, did you have something you wanted to add?
Yeah, a little bit of promotion here. We just heard about the workshops and tutorials results from JCDL.
Right.
Yes,
Yeah.
and so we are doing a workshop on analyzing Web Archive data at larger scale. Make sure register for that. And Matt Kelly is leading the Waddle as always. So keep in mind to submit to that as well. We don't want that workshop to die because no one submitted to it. That's it.
All right. Yeah. Excellent. That's a good point. Matt, do you want to post a URL for Waddle or?
Yeah, we just heard about it last night, so there's not a site for it yet, but it's going to be at JCL this year in Texas. It was at Hypertext last year because we weren't certain about the location. So you should be seeing some announcements from the Web Archiving and Digital Libraries workshop coming up soon, but we should have reasonable deadlines, and I'll send it around to the WSDL list when we have a site up.
Oh, excellent. Really appreciate it. So again, thanks so much for everyone for presenting, for being here, listening. Really appreciate it. This ongoing research collaboration. Y'all have a good rest of your day. Thanks so much. Bye.
Bye, everyone.